Good morning, students. This is Mrs. Sati Joseph, your science teacher. Welcomes you to the online teaching for the session 2020-21. Let us continue with the same chapter, that is chapter 11, Force and Pressure. Before starting the new topics, let us have a quick revision of the topics what we had learned in the previous two modules. The first module, we had seen the definition of force. What is force? Force is a push or pull which makes a change in the state of an object. An object can exert a force on another object when they are in contact. Some examples related to this topic also I had explained. The second video, we had discussed about the effects of force. What are the effects of force? We will recall it one by one. A force can change the state of the object. That means a force can bring an object in motion which is at rest. Also, if an object is in motion, by applying a force, we can bring it to rest. A force can change the direction of motion of the object. A force can change the speed of the object. Either it can increase the speed or decrease the speed, or it can bring to stop the motion of the object. Also, a force can change the shape of the objects. We also learned about what is a contact force and examples for contact forces. Are you remembering, children? What is contact force? Yes, a force which can exert by an object on another object when they are in contact. Such forces are called contact forces. Muscular force, force of friction, etc. are examples of contact forces. Today, in this module, we will discuss about non-contact forces and its examples. I told you earlier that a force can apply by one object on another object when they are in contact. Whether it is essential for the agent applying a force on an object to be always in contact with it. Let us find out. We will see one activity. Before explaining the activity, let us recall what you learned in class 7 about magnets. What is a magnet? Yes, magnet is a substance which can attract iron, nickel, cobalt, etc. There are different type of magnets like bar magnet, horseshoe magnet, etc. A magnet has two poles, a north pole and a south pole. And there are two properties of a magnet. The first property is that a freely suspended magnet always shows the north-south direction. And the second property is like poles repel each other, which means a north pole repels a north pole and a south pole repels a south pole. Whereas unlike poles attract each other, means a south pole attracts a north pole and a north pole attracts a south pole. Now let us see the activity. Take a pair of bar magnets. What is a bar magnet? Bar magnet means a magnet which is in rectangular shape. One end of this bar magnet shows a north pole and the other end shows a south pole. Place the longer side of one of the magnets over three round-shaped pencils or wooden rollers as shown in the figure number 10 in your textbook. Now, bring one end of the other magnet near the end of the magnet placed on the rollers. Make sure that the two magnets do not touch each other. Observe what happens. Next, bring the other end of the magnet near the same end of the magnet placed on the rollers. Note what happens to the magnet placed on the rollers every time another magnet is brought near it. See the first figure. Here you are bringing a north pole of a magnet near to the north pole of another bar magnet which is kept over three pencils. What you can observe? You can observe that the bar magnet which is kept over the pencils moves backward. Why it happens so? As I told you, there is a repulsion between the like poles. So due to repulsion, the bar magnet moves backward. Now come to the second figure. You are bringing the north pole of a bar magnet near to the south pole of another bar magnet which is kept over the pencils. What you observe? You can observe that the magnet which is kept over the pencils moves towards the first magnet. Can you give the reason? Yes, it is because there is an attraction between the opposite poles of the magnet. That is, the north pole attracts the south pole. Because of that, the second magnet moves towards the first magnet. When I explain the effect of force, that time I told you a force can change the state of an object. Here, the magnet moves backward and forward. Does it mean that some force must be acting between the two magnets? Yes. As I told you, that like poles of two magnets repel each other and unlike poles attract each other. So here attraction or repulsion between the can also be seen as another form of pull or push. And the other name of pull or push is the force. So there is a force acting between the two magnets. Because of that, the bar magnet, which is kept over the pencils, moves backward and forward. Do you have to bring the magnets in contact for observing the force between them? No. The magnets are not in contact, then also a force is acting between them. So the force exerted by a magnet is an example of a non-contact force. The two bar magnets are not in contact, then also there is a force between the magnets. So it is an example for non-contact force. Similarly, the force exerted by a magnet on a piece of iron is also a non-contact force. Let us see some more example for non-contact forces. See activity number 7 given in your textbook. Take a plastic straw and cut it into nearly 2 equal pieces. Suspend one of the pieces from the edge of a table with the help of a piece of thread as shown in figure number 11. Now hold the other piece of straw in your hand and rub its free end with a sheet of paper. Bring the rubbed end of the straw near the suspended straw. Make sure that the two pieces do not touch each other. What do you observe? Next, rub the free end of the suspended piece of straw with a sheet of paper. Again, bring the piece of straw that was rubbed earlier with paper near the free end of the suspended straw. What do you observe now? You can see that a straw rubbed with paper attracts another straw but repels if it has also been rubbed with a sheet of paper. If only one piece of straw is rubbed with paper and brought near to the other piece of straw, there will be an attraction. Whereas, if both the straws are rubbed with paper, and brought near to each other, there will be a repulsion. A straw is said to have acquired electrostatic charge after it has been rubbed with a sheet of paper. So when you rub the straw with a paper, it will acquire electrostatic charge. So it is an example for charged body. Now the force exerted by a charged body on another charged or uncharged body is known as electrostatic force. What is electrostatic force? The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. So electrostatic force is also an example for non-contact force, because it can exert a force on another body when they are not in contact. Another example for non-contact force is gravitational force. Do you know what is gravitational force? I will explain it with some examples. Suppose you are throwing a stone in the upward direction. What will happen after some time? It will come to the ground. The leaves or fruits also fall to the ground when they get detached from the plant. Why it happens so? Can this happen without a force acting on it? If it happens by the action of a force, then which force is that? Let us see. Objects or things fall towards the earth because it pulls them. The earth attracts every object towards its center with a force. And this force is called the force of gravity, or you can call it gravity. So what is force of gravity? Force of gravity is the force with which the earth attracts every object towards it. This is an attractive force. The force of gravity acts on all of us all the time without our being aware of it. So it is because of the earth's gravity, water begins to flow towards the ground as soon as we open a tap. It is because of the force of gravity, water in rivers flows downward. Gravity is not a property of the earth alone. In fact, every object in the universe, whether it is small or large, exerts a force on every other object. This force is known as the gravitational force. So what is gravitational force? Every object in the universe attracts every other object with a force. And this force is known as the gravitational force. So today we had learned what is non-contact force, and its examples. This is the end of today's module. Go through the portion, read it nicely. We will continue the same chapter in the next module. Till then, thank you and bye-bye.